So we're going to take a look at drive axle carrier fundamentals and service. We're going to look at a couple of different types and styles of differentials, but a differential, no matter what we're looking at, will always do the same thing. So whether it's an off-highway differential, where we have an articulated machine, the differentials will do exactly what an on-highway does, they're just larger. So one of the things we need to know is what is the weight that this machine is going to be hauling, because it makes a difference in the size of the rear axle. If we have a rear axle that is too small, it's going to tear it apart. So we have to look at that if we're ever speccing a vehicle out. The other thing is a gear ratio of a rear differential. So let's just, for instance, say we have a highway truck. What are we going to be using a highway truck for? So what size of differentials do we need? Are we going to be hauling a heavyweight, a lightweight? Do we want high road speed, low road speed? So the gear ratio really does make a difference on the application of the vehicle. So for instance, if we take a look at an off-highway vehicle that has a front-wheel drive, so we're going to have a transfer case. We're also going to have a front diff, and it's going to have an interaxle in it. So these diffs, one of the big things, they all have to be the same gear ratio. Otherwise, as soon as we engage a locker, it's not going to move. It'll just stop where it is because of tire size rotation. So if all the tires are the same size, they all roll at the same rate. Now what happens internally within each of the differentials is if we're going along in a straight line, everything's working fine. If we have a different gear ratio, it means that one of the wheels can rotate a larger diameter than the other. So within the differential, we have our drive shaft. This is our input pinion, which runs against a crown gear. Now, for instance, let's just say that for sake of argument, this is 5-to-1. So every 5 times the drive shaft turns, the crown gear is going to turn once. Now, the other thing that we see inside a differential is we see planet pinions and side gears. Now, we need these to allow a vehicle to go around a corner. The outside tire is going to have further to travel, and so this pinion here on the outside has to travel faster than the inside pinion. If we didn't have these, or if they were locked together, the tires on the outside would skip. They would scrub, so we can't have that. So if we take a look at the power flow inside a differential, it comes in through the input shaft. It comes into the pinion gear, which runs against the crown gear. Now there's a case half that is bolted to the crown gear. From there, when the crown gear turns, the case half turns, but our axles are both splined to side gears. And with the pinions internally, they can turn at different speeds. So if you lift up an axle with the brakes released, spin one axle, if the transmission drive shaft doesn't turn, you'll notice that the other wheel turns in the opposite direction. And that's all to do with the side gears and the pinion gears internally. Now, this is assuming that we do not have a locker inside the truck. So taking a closer look, so our power flow again would be through from our pinion gear to our crown gear to our case half, and it'll also go through the side gears and the pinion gears. So if one of these pinion gears was missing, we'd be stuck in neutral because it just won't go anywhere, because there's nothing to drive these side gears. These pinion gears need to be there to drive the side gears that are splined to the axle shafts themselves. So this is a very simple drawing again. So what happens when we go around a corner? Well, if we're traveling straight ahead, both axles will be turning at the same rate. But as soon as we go around a corner, the outside axle has to have a further distance to travel, so it's going to rotate at a different speed. As long as the vehicle maintains the same speed, whatever one axle gains, the other axle is going to lose. So if our crown gear is turning at 100 RPM and we start to go around our corner, our outside axle turns at 120 RPM. The inside axle has to lose 20 RPM. So as long as our crown gear speed remains constant, one will gain, one will lose. And that happens all internally inside our case half. Now, the other thing we talked about earlier was lockers. Now, there's a bunch of different styles of lockers that we take a look at. There are some of the lockers that will lock an axle from side to side. There's also an interaxle differential which will lock the front axle to the back axle so that there's no slip. Now we can lock up all four. So our front axle or differential might have an axle lock. Our rear one might have an axle lock, and we'll always have a differential lock so we can lock the front to the back. So if you have a full lockup, that means that all four wheels are driving at exactly the same speed. Now when we get into bigger off-highway equipment, the axles and the setup are going to be a little different. They're for most part, the rear differential of a highway truck is splash lubricated, which means that as the crown gear spins around, it picks up the oil and lubricates the bearings and also the pinion. On off-highway, the speed isn't enough, so what they have is they have a pump and a reservoir, and this keeps this lubricated at all times so that because of the tremendous loads, we don't want them starving for lubrication. So as we're taking a differential apart, now again, there are different functions that a differential may have. For instance, if we have a single axle, we can have a 2-speed differential. So we might have a 5-speed transmission with a 2-speed differential, which will give us 10 speeds. On a highway truck, we cannot run 2-speed differentials because to synchronize the shifting of both of these would be almost impossible. If one gets stuck in neutral, then we have a problem. So you'll only see a 2-speed rear axle on a single axle vehicle. Now, the other thing that we see, because of the tremendous loads, this differential has what's called a thrust pin. Now the thrust pin, because the crown and pinion are working against each other, because of the axial loads placed on them, it wants to push the crown gear away from the pinion as it's turning. So what they have on some machines is they'll have what's called a thrust pin. The thrust pin prevents that crown gear from getting pushed away. It supports it. Now the other thing that we might see on some vehicles are outboard planetaries. Now we've talked about planetaries in transmissions, but in differentials we might have an inboard planetary, or we could also have an outboard planetary. Now outboard planetaries are much easier to service. We can look at them. Inboard planetaries, in most cases, the axles have to, or the housings have to come apart to take a look at the inner planetary setup. So again, if you remember from planetary setups, we have a sun gear, planet carriers, and a ring gear. Now, again, most of these setups, the ring gear is stationary, and the planet carrier, where these yellow pins are here, are what rotate the tires. And the ring gear is held stationary. The other thing we have is outboard braking systems. And again, these are multi-disc braking systems, and in most cases they're lubricated by oil, and that's just to help for wear. So we could have, again, inboard planetaries with an outboard planetary. And again, these are all to give us a gear reduction. And that's what we're after. So that if we want a slow moving vehicle, we can have inboard planetaries with an outboard planetary. Now, because these final drives take a tremendous amount of load, shock loading or overloading is one of the biggest problems we have. You think about this haul truck, let's just say that the haul truck itself weighs 200 tons. It can probably carry 200 tons. So we got 400 tons sitting on that back wheels. And any shock load, and I've seen it before where they're bouncing down the road, and what happens is you think about the tremendous amount of stress that's placed against all these bolts. And what I've seen is the case just shear off right here. So again, we got to take that into account when we're looking at vehicles, examining them for any problems. One of the big indications that we have a differential problem is high temperature. It's for anything, engines, transmissions, differentials. The temperature starts going up, we should be looking to see what's causing it. It might only be a faulty sensor, but it also could be a problem with the differential itself. Now, differential assemblies, again, they vary. It can be a 1-to-1 gear ratio. We don't need to have a 4-to-1, 5-to-1, 4.11. It doesn't matter. We can have anything we want. We can just spec it out. But we still have to have inside we still have to have these components to allow one wheel to travel further than the other wheels. So we're going to see a Spyder with our pinion gears and our 2 side gears. And again, our side gears are splined, so our axle shafts will slide into these. Now, how they pivot depends on the manufacturer and how they have them set up, so that each solid axle can pivot independent of the other ones. So let's take a look at the housing first. So a carrier housing has to be heavy duty. It has to be able to support the loads that are placed on it. Remember, our drive shaft comes in the front, and what's happening internally inside here is the crown gears trying to push the pinion away. And that's one of the reasons why when we take a look at our input shaft, why this is preloaded. Now, if you remember, what is a preload? Well, preload is a load placed on a component before a working load is. And what does a preload do for us in the front diff, or the rear diff for that matter? Well, it prevents the deflection of the crown and pinion. So again, as the pinion's turning, it's trying to force that crown gear away from it. Well, if our bearings were loose, and that can happen very easily by having number 29, if this nut is loose, this yoke can pull ahead, and what happens then is our spacer, number 23, okay? Now this number 23 is a spacer that has a certain measurement, and what that does is keeps this bearing here and this bearing here at a certain distance apart. Now, if this nut comes loose and this yoke moves out, this bearing clearances increases, which now will allow my pinion shaft to deflect away from my crown gear. And what happens then, instead of the gears running nice and true, or if we take a look at gears like this, instead of them running nice and true, they'll be out on the tips. And again, we know from looking at other gearing that that's the weakest part. A shock load will snap off a tooth. So again, it does show up. So there's a couple things that we want to take a look at. Driver comes in and complains that he hears a noise when he's coasting. And that's a good indication that one of the pinion nuts have come loose. And now as he's coasting, you'll get a noise. The other one is traveling straight ahead. You hear nothing, but as soon as you go around a corner, you start to hear a noise. And what that is if we take a look at these pinion gears, As they start to wear, we're going to start to get noise. And these only work when we're going around a corner. So, a couple different setups that we have. We have what's called an amboid. So an amboid is where our pinion is above the center line. We have a hypoid, where the pinion is below the center. And we have a center or straddle mount. Now, if we go back and take a look at the very first one, this one here is just a crown and pinion. Again, it'll have a preload on this bearing. But if you notice on this one, there is no stub shaft. Where we go to this one, we have a stub shaft, and we go to this one, and we have a stub shaft. Now, what is the purpose of the stub shaft? Well, it does the same thing as it helps prevent the pinion and the crown gear from coming out of alignment. So the pinion, you don't want to force it to one side, because again, then we're going to have tooth contact near the tips. Same thing with when we look at this one. Now, another thing that we got to pay attention to is our crown and pinion identification. So there's numbers on them, part numbers, heat treating numbers, tooth combination, 39 to 6. Okay, so our crown gear is going to have 39 teeth, our pinion's going to have 6. They should match. The other thing that we're going to see is a pinion etch number. Now this pinion etch number, we'll talk about how it's set up. Now the other thing we want to see is like a 268. Now these are sold as a match set. If we break a crown tooth, we can't just put any crown in. We have to replace them as a set. The other thing that you're going to see is a thrust plug. Now again, under load, the crown and pinion want to deflect, and the pinion gear wants to push the crown gear away. What this thrust plug or thrust screw does is it sits up close to the crown gear and prevents that deflection of the crown gear. So this has to be set. So you'll set this in until it touches, and then you'll back it off whatever the specification is. Let's just say the specification is 20 thou. So it will say back it off, say 1/2 of a turn, and that 1/2 of a turn will be the 20 thou. And then you lock the jam nut. Now on the older thrust screws, before they just had this brass end, they used to have a foot sitting on here. And what would happen is someone would undo the screw enough that the foot would hit on here and then fall off into the bottom. Then it would get caught up in the gears and damage it. So they've got rid of those shoes that were on here that would run against the crown gear. And we take a look at our differential assembly again. So we have our crown gear, we have our outer bearings, and we have our inner bearings, so left and right hand bearings. We also have our differential assembly. This is our case half, and this is bolted or riveted to our crown gear. So what's inside there? Well, we have our pinion gears, we have our pinion washers, we have our side gears, and our thrust washers. So what's happening is, as if we're going down the road straight, nothing inside is moving. Both wheels are turning at the same speed. But as we start to go around a corner, one wheel is going to turn faster, which is going to allow this side gear to turn faster. Remember, the other side is going to turn the same amount or lose the same amount as this one gains. But that all travels through our pinion gears. Now, why do we have pinion thrust washers? Well, as this is spinning, it's to take up the load. And it's the same with our side gears thrust washers. So we want to make sure that these, if we're ever inspecting it, that we're going to, number one, mark the case half before you take it apart. What we're going to be looking for is any damage to the teeth, any damage to the thrust washers, any damage to the cross, and any damage inside the case halves where the thrust washers run. Because if these start to wear in the case half, you have to replace the case half. There's no repair for them. Now, the other thing that we take a look at is the load. So if we have 1,000 foot-pounds of load coming in, and we have a 3-to-1 differential, we're dividing that load 1,500 foot-pounds per axle. Now, what happens if we have a wheel spin? Well, the amount of torque that's going to go to the opposite wheel, and this is a differential that does not have a locker, the amount of torque it takes to break this wheel free is the same amount of torque that's going to go to the other wheel. That's why we have lockers, is so that we can lock this up and allow this wheel that's on solid ground to move. So always remember that the amount of torque it takes to break this wheel free is only going to be transmitted to the other side. Okay, now we've already talked about going around a corner, and again, taking a look at the speed differential. If our bevel gear is turning at 100 RPM and we go around a corner and this one turns at 120, the other side's going to turn at 80. The amount of torque is still going to be the same to both because both wheels are still driving. None of them are on ice. Now what happens if I break an axle shaft? Or for instance, this wheel's on solid ice. That one's going to turn twice as fast because this one isn't moving. So if the right hand one's on solid ice and the left hand one is on solid ground, what's going to happen is this one won't turn, but this one will turn twice the speed. Okay, now when we get into heavy equipment, so we're going to have a transfer case which is going to allow power to the front axle and rear axle, and let's say it's through a drive shaft. Again, front axle and rear axle or differentials have to have the same gear ratio or it's going to try and scuff the tires. And so we've already talked about transfer cases and power flow, so we don't need to go over that. Now, what about lockers? So there's a couple different types of lockers that we're going to take a look at. One type of locker is where we can lock an axle to a case half. Now, this axle will be splined. The sliding collar is got the teeth on it, and it's splined to the axle shaft. So anytime that axle is rotating, this collar is rotating. This other collar is locked to the case half. Now, when these two are locked together, this axle gets locked to the case half. And if you remember back from a picture where we have side gears, let's just go back and take a look. So what happens is the axle comes in and goes through this side gear. If we're locking the axle to the case half, this side gear can't turn, neither can this one because it's turning as a complete unit, which now locks your right-hand axle with your left-hand axle. And that's really what we're looking for when we take a look at a locker. So this will lock my right-hand side to my left-hand side. I can have this type of locker on the front axle also. And the other one that we're going to see is what's called a differential lock, which will lock the differential so it locks the front to the back. So taking a look at something like this is where we can have a mechanical shift, whether it's air or electric, so that it'll lock the two together. So we can also use clutch packs. So there's a bunch of different varieties that you're going to see. So for instance, on a pickup truck, you might see these clutch packs. So they have a clutch pack on the left-hand side and they could have a clutch pack on the right-hand side. And those are a limited slip. But with just a single clutch pack, this is splined to the axle shaft. And as soon as we engage that clutch, it's going to lock this axle to this case half. And now that this axle can't turn, it has to turn as a unit. Now this is more of a pickup that we're going to see. This is where we have clutch packs left and right. So as we're driving straight ahead, both these clutch packs are free. As we start to go around a corner or one wheel starts to slip, the clutch pack will engage so that we don't lose our torque to that wheel. The other thing we might see is what's called a Detroit locker. Now, Detroit locker is locked at all times. So these are our side gears. So our axles are splined to these two. We have a spring and we have a spring retainer, and we have our two clutches. And here's our spider, so our pinion gears will run on this. And what happens is as we're traveling straight ahead, both sides are engaged. But as we start to go around a corner, what would happen if this stayed engaged is one of the wheels, because it travels faster, will start to slip. So what happens is as we go around a corner, the teeth disengage and allows this side gear to travel at a different speed than this side gear. And that's it for this video.